Hi everyone, so let's take a look at question 2 and question 3. Okay, so the first question says describe the following geometries. So here you can't guess that this is a circle, this is a parabola, this is a parabola, or maybe this is an ellipse. You can't guess. So how do you know that? You complete the square of these equations, and then the result that you are going to get is what to simply tell you that this is a circle or this is an ellipse. So let's start with the first one there. So the first one is A. This is question 2A. So we have 16x squared plus 9y squared minus 64. So minus 64x, then you have minus 54y plus 1 is equal to 0. So this is what you have. So the first thing, you pair the like terms together. So we're going to pair 16x squared and negative 64x. Then we also pair 9y squared and 54y. And then we take this one to the other side of the equal sign. So here starts now the matter of factorizing. So we factorize 16 there. We're going to have x squared minus 4x close brackets, and then there we're going to factorize 9. We're going to have y squared minus, I think 9 into 54, that should be 6y is equal to 1. So from there we can now complete the square of this part and this part. So we're going to have our 16 there. We open the square brackets, then we're going to have x squared there, and then we find half of negative 4. So half of negative 4 is simply just negative 2. You square it, then you say minus the same thing here, negative 2, you square it, then we say minus 4x, you close the brackets. Then you also do the same there, you open square brackets. You are going to have y squared, half of negative 6 will give you, so half of negative 6 gives us negative 3. So we have negative 3 there. Okay, so we have negative 3 there. We square it, then we subtract the same negative 3 squared, then we have 6y there. Okay, so from there we say this is equal to sorry, not 0. Okay, so this is equal to 1. Then let's complete the square of these first two terms even there. So we're going to have 16 there, and then we open these same square brackets. When we complete the square of this part, we're going to have x minus 2 in brackets and then squared. Then we say minus negative 2 squared gives us 4. Then you forget about this, so you're going to say plus 9, and then you do the same to that part. So you're going to have 9 minus 3, and then squared, then minus negative 3 squared will give you 9. Yeah, so negative 3 squared will give you 9. Then from there we close the brackets. Then this is equal to 1. Okay, so let's move on. So from there we're going to say 16 times 4, I mean we open the bracket, 16 times this, we're going to have 16 open brackets x minus 2 squared. 16 times negative 4, this will be negative 64. And then we say plus 9 times that, this will give us 9y minus 3 squared. And then 9 times 9 there will give us 81. This is equal to 1. So when you add 64 and 81, so you get something like 1. This should give you something like 145. Yeah, so you have 16 And by the way, I've just noticed that when this positive 1 went to the other side of the equal sign, it's supposed to have a negative in front. They're supposed to have a negative in front there. It's supposed to be a negative in front. Okay, so from there we can now say x minus 2 squared, and then we have positive 9 y minus 3 squared, then you have negative 144 there, oh sorry, 145, is equal to negative 1. So when you take this to the other side of the equal sign, you are just going to have 16 there, then you have x minus 2 squared, then plus 9y minus 3 squared, then this will be equal to negative 1 plus 145. So when you add this, you have something like this: x minus 2 squared plus 9 y minus 3 squared is equal to 144. So after doing that, you now move on to remember of the between the two conic sections that we've talked about. Sorry. Remember, I said for the ellipse, this side you are just supposed to have a 1. You don't need to have any other number apart from a 1 this side. And then the coefficients here, they are all supposed to be 1s. This part here is not supposed to have any coefficient. Even this part is not supposed to have any coefficient in both conic sections that we've looked about. That we've looked at. So to get rid of this 144, to get rid of the 16 and the 9, we can divide everything by 144. So I'm going to divide this part by 144, and then I'll also divide this part by 144, even this part by 144. So from there we're going to have something like this, squared over. So when you divide this 16 into 16 is 1, then 16 into 144, this will give you 9, and then we say plus. When you divide 9 there, it's 1, so you just remain with y minus 3, and then close brackets, and then squared 9 into 144, this will give you 16. Then this is equal to 1. So just by looking at this, you can know that this conic section or this geometry is simply just an ellipse. So yeah, this is just an ellipse. So after finding that it's an ellipse, the next thing that you do is to find the center, the vertices, yeah, and other things, and then at the end of everything you sketch. Yeah, so the center here, you just equate what is in the brackets there. You have x minus 2, you equate this to 0. You also equate y minus 3 to 0. So when you do that, this part will give you x to be equal to 2, and then this other one will give you y to be equal to 3, meaning the center will now just be equal to 2, 3. Then let's now find the vertices. How do you find the vertices? We first have to identify which one is our A, which one is our B. So our A, according to the ellipse, we know to say A squared is always greater than B squared. So for this reason, we can tell that the number which is bigger than the other here is 16. So 16 is the one that we're going to get as our A squared. So our A squared is equal to 16, meaning the value of A becomes 4. And then the other thing you have to look at is your B. So B squared is equal to 9. So B squared is equal to 9. the value of b becomes 3. So now let us find our c. We know that c squared is given by a squared minus b squared. So c squared will now be equal to, our a squared is 16 minus 9. So 16 minus 9 gives us 7. So our c is now just going to be equal to the square root of 7. So after finding this, we can now find the vertices. So the center is there, so we find v1. So v1, we know that since a is under y, meaning the ellipse is in the y. So if the ellipse is in the y-axis or it's along the y-axis, means that we're going to maintain our x-coordinate, and then what will just be changing is the y-coordinate. So how do we now get the v1? So we get our value of a. Our value of a is 4, and then we're going to add it to the y-coordinate. So v1 will just be 2 comma 3 plus 4. We are going to get 7. And then v2 will now be 2 comma 3 minus 4. 3 minus 4 will get negative 1. Okay, so from there we get the minor vertex. So m1, in the m1, the minor, if the major is in the y, meaning the minor will be in the x. So since the minor is in the x, meaning we're going to maintain our y coordinate, and then what will just be changing is the x coordinate. So we're going to add and subtract b from the x coordinate of the center. So we say 2 plus 3 will get 5, then this will be comma 3, and then m2 becomes 2 minus 3, we get negative 1 comma 3. Then after finding the minors, we can now find the focus. So f1, we just get the value of c there, we add it to the y coordinate. So f1, we say, so this will be 2 comma 3 plus root 7, and then we are going to have, okay, let me just remove this. Okay, so f1 becomes that, and then f2 will also be 2 comma 3 minus the root of 7. And then from there we can now find the length of the minor and the length of the major. So the length, start with the length of the major axis. The length of the major axis is given by 2a. So 2a, our a is simply just 4. So put 4 there, which gives us 8. And then the length of the minor axis, the minor axis is just 2b, which gives us 2 times 3. This is equal to 6. Then from there, the other thing we need to find is the eccentricity. So we know that E is just given by c over a. So our E is root 7 over 4. So once you are just done writing this, means that you are 90% done with the describing of the ellipse. So let us now go to sketching. Let us sketch the ellipse. So do I have space on top? Okay, let me just get this. Alright, let us sketch the ellipse. Okay, so these are the things that we found. This is the data that we found. So let us now start sketching. So we know that it's in the y because the value of a was under y. So we're going to write something like this. Then the center we found was 2, should be 2,3. Let me check. Yeah, it was 2,3. Okay, so the center was 2,3. So we expect to have something like this. So let me just write the center here, 2,3. So 0 there. Then this is what we're going to have. So v1 is 2,7. So I'll count 1, 2. So this is 2. Then 1, 2, 3. This is my 3. So this is where our center is. And then this is our center, 2,3. And then v1 is 2,7. 3, 1, 3, 4, 5, 6, 7. So this is our 7. And then v2 is 2, -1. So this will be, so my -1 is there. So the other v2 is there. So this is my v1, this is my v2. Then we also put the minus 5, 3, 2, 1, 2, 2, 3, 4, 5. So 5, 3. Then this side we have -1. So -1 there, 3 somewhere there. So we can now sketch this. Okay, and then from there we can now put the focus. So we have the first focus we have is 2, 3 plus something. So the root of 7, the approximate number for the root of 7 is simply just 2.6. So 2 plus 2.6, simply something like 5.6. So we can approximate our focus to be 3, 4, 5, 5.6, somewhere there. So our focus will be somewhere there. So this is where our f1 will be. Then our f2, when you subtract 3 minus 2.6, that should be 1 point something, which is also something somewhere there. So this is our f2. So that is how you deal with. So this is my center. So if you want, you can put the numbers there. v1 2,7. Then this one is 5,3. This one, so this is m2. Sorry, this is m1. Then m2. m2 is -1,3. Then this one also you put your v2. Sorry, let me just write it here. v2 is 2, -1. You also put your center there, which is 2,3. You also write the coordinates of the focus. So you have 2, 3 plus the root of 7. Then even there you have 2, 3 minus the root of 7. Yeah, so that is basically how you do your sketching. So this question is done. Let us move on to the next one. Okay, so the next question is B, which is here. So we do the same even for this question. Even for this question we do the same. We first pair the like terms. So the like terms we have there is, we have x squared, then minus 2x, then we also have positive y squared minus 6y, then is equal to 26. So from there we can now, since we don't have anything to factorize here, it's just a matter of finding half of -2 there. Half of -2 is simply just -1, then we square it, we subtract the same thing, then we say minus 2x, then we say plus y squared. Half of -6 there is negative 3, we square it, then we subtract the same negative 3 squared, then we write that negative 6y, this one, and then we say this one is equal to 26. So we complete the square. We're going to have x minus 1 squared, then minus 1, then plus we have y minus 3 squared, we have minus 9, when you square that, and then this is equal to 26. So when you add negative 1 and negative 9, you get negative 10. So you're going to have something like this. Okay, wait. Okay, so you're going to have minus 1 squared, and then you have plus y minus 3 squared, then minus 10 is equal to 26. You take this 10 to the other side of the equal sign, you have something like this. 26 plus 10, and then you write this. Okay, so you have minus 1 squared, then you have y minus 3 squared is equal to 36. So just by looking at this, since we don't have any coefficients this side, so we can't say we divide by 36 for us to make a 1 this other part. No, if we had coefficients here, yes, we would have done that. Yeah, we would have done that. Or if we had a number here dividing any of these two, would have divided by 36 so that we remain with the 1 this side. But in this case, we take this as a circle. A circle. Then how do you describe the circle? You find the center by equating what is in the brackets there to 0. So we equate what is in the brackets to 0. Even this side we equate to 0. So the value of x is 1, the value of y is 3. So the center of this circle is simply just so the center of this circle is simply just 1,3. After finding the center, we find the radius. We know that r squared will just be equal to the number that is this side, which is 36. So r squared is equal to 36, meaning the value of r is simply just 6. So this is a circle with radius 6. So we can even sketch it just even here. So we have the center of the xy plane there. Then the center is 1,3 somewhere there. Then we count 6 steps going to the right and 6 steps going to the left. 1, 2, 3, 4, 5, 6. Sorry, this should be 7. Okay, and then here we count 6, 3, 1, 2, 3, 4, 5, 6. So this should be 9. 4, 5, 6, 7, 8, 9. Yeah. Then this side we count 6. 1, 2, 3, 4, 5, 6. So this should be 5. Then we count 6 going down. 1, 2, 3, 4, 5, 6. This should be 1, 2, 3, 4, 5, 6. This should be -3 then. So you just join the points to make your circle. Then draw it well. Yeah, but it's a circle. Yeah, it's a circle with radius 6. So that's basically how you do the sketching for the second question. So let's quickly move on to the last question, which is question 3. Okay, So question 3, the question reads, find the equation in standard form of each ellipse given that the major axis is of length 8 and the center at 0, 0. The ellipse passes through this point. So one thing you need to understand about this ellipse is that, okay, first let's draw let's put up the general formula for all the ellipse. We know that the general formula for the ellipse is simply just x minus h squared over, this can either be a squared or b squared, then plus y minus k squared over, this can also be b squared or a squared, depending with the with where the depending with where the ellipse is, if it's in the y or in the x. And then this side is always supposed to be 1. Now since the center is 0, 0, so we expect our ellipse to have x, not having 0, not having h there, so we just expect our ellipse to have x squared, because when you put 0 there and 0 there, we just remain with x squared on top. Then this side will also remain with y squared, then over, so we have this being equal to 1. So now the question says, we don't know which one is our a, which one is our b. The question says this ellipse, the standard form of the ellipse, given that the major axis is of length 8. So the major axis has the length 8. So the major axis has the length 8. So which tells us to say, we know that the length of the major axis length, I don't know how I can abbreviate this, but okay, let's just take it, since this question is just alone here, so we can just say major axis, whatever we've written here means major, not minor. So major axis length is given by 2a, major axis, not minor, okay, 2a. So our major axis length has been given to be 8, so this is 8 is equal to 2a. So meaning the value of a, becomes, so the value of a is going to, when you divide 2 on both sides, so we have 2a is equal to 8, we divide 2 this side, divide 2 this side, the value of a is going to be 4. So at least we know the value of a, and then they are telling us to say this, and they are telling us to say this ellipse passes through this point, meaning the x and the y coordinate at this point is -2 and 2. So we don't know whether this ellipse lies in the x or in the y. So what you just do is you replace -2 and 2 where there's x and y, and then you are going to put this a on any of these two. Then the answer that you get, that will be your b. So let's do that. So we replace, so what I meant was, we don't know this, we also don't know that, so but we've managed to find a. So our a squared will give us 16. So what we do is we put x there, we put -2 there, then we square it, and then we say over. Our a squared is, you can put it on either b or a, I'm sure you get the same answer. So you have 16 there, then plus y, you also put 2 there, then over b squared is equal to 1. So this is just a matter of simplifying. So you have 4 over 16, and then plus 4 over b squared is equal to 1. So this can be written as 1 over 4 plus 4 over b squared is equal to 1. When you take this to the other side of the equal sign, let me just demarcate here. Take this to the other side of the equal sign, you are going to remain with 4 over b squared this side. Then you have 1 minus 1 over 4. When you subtract this, you have 4 over b squared is equal to, this will be 3 over 4. So to find b squared, you just make b the subject of the formula. So meaning you have your b squared being equal to, or let me just do it step by step. So we make b squared the subject of the formula. So we cross multiply here. So when we cross multiply, so when we cross multiply here, you are going to have b times 3, b squared times 3, you have 3b squared is equal to 4 times 4, you get 16. So you divide by 3, divide by 3, and then our b squared becomes 16 over 3. So 16 over 3 is our b squared. Okay, so that is how you basically solve this equation. So you replace your b squared where it's supposed to be. So the general formula for this becomes x squared over 16 plus, and then you have your y squared over 16 over 3. That's the b squared that you found is equal to 1. So you can now simplify this further by just writing it as x squared over 16, x squared over 16 plus 3y squared over 16 is equal to 1. So this is basically how you solve this equation. This is how you describe it, this is how you find the general formula given those conditions. So thank you very much for your attention. See you in the next math lecture that we are going to have next time. Make sure that you pay attention so that you get everything correct next time. See you.